Now, the interesting question in terms of human systems is, what are these categories of people, the innovators, the early adopters, the laggards, and so on? In this slide, I show the results of a study that is made in Germany, very representative and big country in the Western world, where different categories of people are mapped according to their social status and the basic values that they use. So there are many of them. I will let you the fun to read what each of these category means, but I will just point out to some of them. For example, if you go on the top right, so the modern performers, that would be 1C box, you will see that actually these are the ones that are the early adopters, the innovators. And the more you go to in diagonal to A3, the more you go towards the laggards through the bulk of the population. And if you read that and try to understand what it means, you may make in your mind some connections with the previous table that I gave you, and that is related to the different styles of management, related to different worldviews, like hierarchist, egalitarian, individualist, and so on. So this is another way to represent different categories across society. Now, when you have to take into account the technological aspects and the human aspects, what people want in this world in fast change, another pattern that happens is the design of a product. The management of this generation of the product is in a big shift right now. Traditionally, there was a sequential approach used, so you see in this slide with blue, which basically consisted in a so-called waterfall dynamics, linear basically, in which you have different categories, one after the other. Once the first requirements are established, then you go to the design, you finish the design, you go to implementation, then to implementation and to verification and to maintenance. Unidirectional. Now, this works for products that are relatively simple, but when it's more complex, it's not possible. You cannot anticipate everything in terms of requirements from the beginning. You just cannot, it's impossible. And the same with the design. You cannot know everything in advance. So what happens now is that more and more an iterative approach is applied, which means repetitive. You repeat a cycle of requirements, design, testing, implementation, and evaluation until you are happy with what you have. Now, this type of design corresponds to, or is more fit to, dealing with nonlinear evolutionary dynamics that we talked in earlier lessons. It can be tricky, so it's very dependent on efficient communication. But as we also discussed in earlier lessons, people in teams learn better and better to communicate and to work together. So after the initial planning, you repeat this circle as many times as necessary until you're ready to go to deployment. So this is the big shift in design. In the next slide, I give a bit of example with the development of a software. So a very well-known method, it is called Scrum, and it consists in episodes of fast development that are represented with this green circle and the arrow here. Basically, if you read this, you will recognize some of the elements that we discussed when we presented the Delphi approach with prioritization and the decision trees. Here you have some initial modeling, planning and organization, and then you have your long list of things that you may want to do. Then you prioritize them, only take those and put them into a process, You make the analysis and you do a so-called sprint. The sprint is a cycle of 2 to 4 weeks in which, based on your requirements, you develop a software. You have a meeting at the end of every cycle, but also have meetings every day with different tasks for every day. And it's organized by a so-called Scrum Master that takes care that everyone knows the tasks and the problems that might arise, and they discuss very quickly daily. Then you are ready for testing, and then after you've had enough test, you release it for the production and deployment. An interesting detail here, you can read also for yourself if you check this very good article, is that these daily Scrum meetings are done standing. You don't have people sitting, because this is supposed to last only a few minutes, so that you only discuss the really important things. That's an important detail. Now, in the next slide, we already go to the question of when are you ready? How many sprints, for example, do you need to do before you think you're ready for the market? Well, the discussion is organized along a number of levels, and the most popular actually, and it's becoming even more popular now, scale is that of the technology readiness levels, which have been generated in the 80s, so a long time ago, and it was then used by NASA, United States, and the Department of Defense, the American Army, because they had to decide in which type of technology they invest a lot of money, because it's a lot of money, without having a big risk of investing for nothing. So these steps of readiness were very important to decide by the experts. And these are in a gradient from level 1, which is basic technology research, to actual system flight proven, so-called, meaning that run through all the tests and it's ready for deployment. The big change is starting with level 7. So basically, science and research is the first levels, from 1 to 3, roughly. Analytical analysis that you do, principles, and so on. At level 7, you need to be ready for demonstration in a system. So how is your technology working in a system, not just when you're sitting alone on a table? In between is the hard part, where you have to validate and develop different subsystems. So you go through technology development and technology demonstration. The important detail today is that this scale has also been taken by the European Commission. So when you apply for funding as a private company, this is possible too, or a research laboratory, you are required now to show how your research and technology that you are working or trying to develop fits along this scale, so that it is easier to be understood in terms of investment too. Now, these scales are being calculated in a simple way. Initially, and even now, it's still it can be done through basically MS Excel spreadsheet. You automate some functions there. So you have a list of questions. For example, what you see here in this table is a long list of questions to which each expert or team of experts are required to ask. And the more questions you ask positively, like about finished, because you have actually the requirement to put your pointer from 1% to 100%. Is it finished, this question? Is it ready? Is it done? You established a threshold, for example, 80%. If your team says votes for each question, for example, it's 85, okay, it goes into green. If you're into green, you're ready for the next level. questions and so on. And this means also that you may not have all questions in one level finished, but you can still begin to answer some questions in the next level. So you gradually go like that, like a wave, where you answer a lot of questions, and then you know where you are. An important detail here that I want to highlight is answering these questions is a matter of expert decision as well. So you don't always have a theory that clarifies, okay, this is done or not. Sometimes, yes, you make a measurement, is it above a certain value? Good, answer yes. But sometimes you have to give your opinion as an expert, individually or in team. So in this sense, it is also resembling our discussion with the Delphi approach. So you see how important is expert decision when it's about complex developments. In the next slide, I just want to show that you can cross these approaches. Basically, these levels or big thresholds along the technology readiness levels can be represented as a decision tree, as I show here. And basically, the major situations would be just science principles, if you formulated the concept. So basically, stage 1 would be there. And then up, you have potential technology, meaning that it looks promising, but you don't know yet if this is going to work. Then you have an emerging technology that really looks good. You did a lot of tests in laboratories, and the next step is just the market. And then the commercial technology that is finished at the end, stage 9. So I show this because all these concepts and methods that I selected in this series for you are supposed to be flexible, to help you in different circumstances, and by being flexible they can also combine themselves. So here's an example of how the technology readiness and the decision trees can be combined. Now at the end, this is a sort of bonus slide. If you go on this link, and I really recommend to click on that full list, you see about 40 insights of what you need to do and what you don't need to do to keep on your right track towards success. Here in the picture you already see the main points related to focus. You need focus. You already know that. Actually nothing is new, but it's important to remind yourself all the time this. Then passion. If you don't like something, you'll hate it. You will hate that job and work, so it will not work in the end. Then you have to push. You know, it's very easy to say, oh, this is not going to work. And usually when you start something new, you have everybody around you telling that, this is not going to work. You are naive. Come on. You have to push. If you have your reasons, you push. It's you that decide. Then to serve others. It's important to try to solve a problem of the people. If you solve a problem of the people, there will be a market for it. If you're just looking for, I want to make money with this technology, you start with the wrong way of thinking and it will not work, so you have no money in the end. First you create the value and then the money will come. Also, the more you get the skills into doing the business part too. Then ideas. The idea is very important. You have to identify a problem and how to solve it. Persistence and hard work. Like Edison was saying, 1% is inspiration and 99% is transpiration, right, in achieving success. So that was it for now. As recommended readings, this time I would give you a report. This is not a scientific article. It's a report made by Science Business, which is an NGO in Brussels, organizing important and high-level meetings between companies and European Commission and academic experts. And here they have a report on energy, how to plan Europe's energy future. This is very relevant for your topic in this master. And I also participate in that, so I know what I'm talking about. You can check it. You will see some highlights and insights related to models, to climate, and to management. In the end, I just wish you here good luck. So I use this picture, and I hope the business environment will be ready for you in just a short time if you do the right thing. And I'm ready to answer your questions, of course, by email and by live meeting. So thank you.